All right, everybody, this is our last video for the week, and in this video we're going to look at logarithmic equations. So you might remember that in our last video where we looked at exponential equations, we had the opportunity to see one example where an exponential didn't end up having a solution because the range of the exponential function doesn't include 0. So the question was, when is e to the power 4x going to be 0? And the answer was never. E to the 4x cannot be equal to 0. Well, with logarithmic equations, this sort of thing becomes even more of a front and center concern, because unlike exponentials, where the domain is all real numbers, meaning you can use anything as an input to exponentials and you don't have to worry about it, the domain of a logarithmic function isn't all real numbers. And if you remember, when we were looking at the inverse of an exponential function, we were reminded that with inverses, the role of the domain and range is reversed. So what was once the domain becomes the range and vice versa. And since the range of exponential functions is strictly positive, the domain of a logarithmic function, meaning the thing upon which logarithm acts, has to be strictly positive. So we're going to have to really keep that in mind when we approach these problems. So I have here 4 examples for us, and we're going to work through them one by one, and they kind of accelerate as we go. So for the first one, we are just going to use the exponential form of logarithm. You'll notice I included it here, and I hope that by now you are really kind of carrying that with you, because that is such a key tool. The most key piece of this week's lessons is that exponentials and logarithms are inverse operations of one another. So the fact that we can switch between exponential and logarithmic relationship is going to be such a huge governing principle. All right, so here we go. We have log base 7 of x minus 2 equals 2. I think you've gathered by now that I'm never going to get sick of this. So I'm going to go ahead and label my A, my B, and my C. So here A is played by 7, B is 2, and x minus 2 is C. So looking at exponential form, a to the power b is 7 squared is equal to x minus 2. Well, 7 squared is 49, right? And then we're going to add 2 to both sides, so x is 51. Now, we should check, is 51 in the domain of our log? Well, we have log base 7 of x minus 2. 51 minus 2 is absolutely positive, so that's fine. So in fact, for number 1, we don't have any domain concerns, and the solution is 51. So now we move on to example 2. So I want you guys to notice something. In example 1, your log was completely consolidated on one side, which is what enabled us to use logarithmic and exponential form. In all of the other examples, you have multiple logs on one side. So the first thing that we're going to do is we're going to consolidate both sides of the equal sign using properties of logarithms. So I'll just say here properties of logs. So this first one, we have a sum. Okay, so that's going to be property number 1. And we actually have a sum on the right-hand side also. So that's also going to be property number 1. Okay. All right. The property that tells us that if we have 2 different logarithms of the same base being added together, it consolidates into one log of the product. So on the left, we have log base 2 of 3 times x. On the right, we have log base 2 of 5 times x minus 2. And remember, log is 1 to 1. So if the log of two things is equal, that must mean that the two things are equal to each other. At this point, we have a linear equation, right? So we can distribute. So 3x is 5x minus 10. And now we can subtract 3x from both sides and add 10 to both sides. So we get 10 is equal to 2x. So x is equal to 5. Now, to say we did, let's actually look at the domains here. So log base 2 of x has to be strictly positive, so the domain consists of all real numbers greater than 0. Log base 2 of x minus 2, the domain is everything greater than 2, because now x minus 2 has to be strictly positive. Log base 2 of 5 and log base 2 of 3, those are constants, so there's no domain issue there. Okay, is 5 both greater than 2 and greater than 0, right? That's what we're looking for here, that 5 satisfies both of them. And yes, it does. So since 5 satisfies both domains, 5 is the solution to this equation. So at this point, you might be thinking to yourself, why do we bother checking the domain if it just always works out? Well, yes, you're right. I wanted to make sure that we were at least given one example where the domain became a problem. So for that, we looked to problem number 3. Again, we have two different logs on the left-hand side. So we're going to consolidate them using properties of logarithms. This is property number 1. So when we consolidate them, we have log base 2 of x times x minus 7 is equal to 3. Now, again, we're going to use the exponential form. So I'm going to do it one more time. Here, a is 2. X times x minus 7 is my c. And 3 is my b. In exponential form, we have a to the power b is equal to c. So c is by itself on one side. A to the power b is on the other. Let's open up parentheses and get rid of exponents. So we have x squared minus 7x. 2 cubed is 8. So we have x squared minus 7x minus 8 is equal to 0. Notice that this is a quadratic equation, right? So what you'll notice in these problems, especially when you do them in homework, is that it's generally going to be a pretty nice quadratic equation that factors really well, so take advantage of that. This happens to factor into x minus 8 times x plus 1. So right now, we're looking at the possibility of the solutions being 8 and negative 1. But wait a minute, we still got to look in the domains. The domain of the first one is strictly positive numbers. So x has to be greater than 0. So it's already not looking very good for negative 1. For the second one, x minus 7 has to be positive. So x has to be strictly greater than 7. Negative 1 does not satisfy both of these things. So negative 1 is out. And I'm going to write here, it doesn't satisfy the domain. That's it. If it doesn't satisfy the domain, it doesn't get to be a solution. 8 does satisfy the domain, so it is a solution. So this equation has a single solution, and that solution is 8. Okay, just to kind of jazz it up a bit to make sure that we're looking at a multitude of different properties, let's finish with example number 4. So in example number 4, we have a difference. And I believe we called that property number 2. Forgive me if the numbering isn't quite right. Go back and look at the logarithmic properties video and use that same numbering if mine doesn't quite match up. So this property tells us that if we have the difference of two logarithms, that consolidates into the log of a quotient. So we end up with log base 3 of x plus 1 divided by x minus 1 equals 2. So at this point, we can use the exponential form one more time. I'm going to call it out. So this is A, this is B, and this whole thing is C. So by the exponential form, one more time, the a to the power B will be equal to C. So we have 3 squared is equal to x plus 1 over x minus 1. So x plus 1 over x minus 1 is by itself. 3 squared, which is 9, is on the other side. This is a rational equation. If you want, we can label that. And what I hope you all remember about rational equations is that the way that we solve them, or at least one way that you can solve them, is multiplying both sides by the denominator. So we end up with x plus 1 is equal to 9 times x minus 1. So x plus 1 is equal to 9x minus 9. So here, now we've got it linear, so we'll subtract x and add 9 to both sides. So 10 is equal to 8x. Divide both sides by 8. So x is 10 over 8, which reduces to 5/4. So not so fast. Let's check the domain. So going back to our original equation, the domain of log base 3 of x plus 1, so x plus 1 has to be positive, so x has to be greater than -1. And log base 3 of x minus 1, it's x minus 1 that has to be positive, so x has to be greater than 1. Well, is 5/4 going to satisfy both of them? Yes, it's definitely bigger than -1, and it's not a lot bigger than 1, but it is bigger than 1. So in fact, 5/4 satisfies the domains, and so that is the solution to our equation. And thus, we finish our conversation about solving logarithmic equations. So I just want to recap. Use properties of logarithms to consolidate into 1 log per side if needed. Once you've done that, use the exponential form to rewrite your equation in a way that doesn't have logs in it. Solve the resulting equation. Might be quadratic, might be rational, might be linear. And after you've solved and you get solutions, don't forget to check that they satisfy the domains, which you determine by looking back at the original equation. All right, so this is our last video for the week. Sorry for the technical difficulties at the beginning, but we have them now. See you next week. Bye.